Alright, hello. I am going to attempt in hopefully well under an hour to demonstrate how to get up and running with TDD, the essential steps to get traction to either start a new program or add existing or features to an existing program. As Jitter Ted mentioned, he would like to see a sped up version of adding a new feature to a program following the TDD cycle, and for myself as well to improve my process and explanation of things, trying to also factor in what Voice of Unreason had mentioned. So anyway, without any further ado, over here I have the TDD steps, which I have slightly refined from my traditional TDD steps if anybody did happen to pay attention to that. So step 1, determine the next desired method, i.e. interface, from the perspective of the application code. Number 2, write just enough test code for a desired interface in the ACK section, blah blah blah. Go through this whole red green refactor type of a cycle here. And going by what Voice of Unreason said, I think this determine next desired method, they were wanting to see that unpacked to the best of my interpretation. And also I believe I've right here at the to cap it off, to bookend it, maybe a little more detail around this refactoring section as well. But the middle part's just write the test code, see it fail against application code. Next step, write just enough application code to see that missing interface test pass come back. Write enough more test code to create an assertion of what you actually care to see. Then of course go back and write just enough application code, even hard coding it the first iteration or two, to see that test pass. And then refactor as necessary to improve obvious weaknesses such as hard coding, duplication, and or, which I have right here, to suss out any issues and correct them. And that's basically cycling around these last two steps as necessary. Don't worry about all that right now because we're going to take it one step at a time. What we have here is a requirements file. Very basic. This is from my experience dealing as a remote freelancer over the years and whatnot. You have a meeting, probably 5 hours, just to end up with some requirements about this big. And for this one, it's calculate tip, hard coded at 20%, have the user input an amount, display the tip amount, display the new amount, including the tip, for example. And this would constitute a minimum viable product, right? An MVP, a first iteration, a few days to a week's worth of work, whatever, depending on the size of the project, your availability, all those kind of cool things. So anyway, this is going to unpack, right? So have user input an amount. So what does that unpack to? Because now we're off on our own. We went away from the meeting or whatever to gather the requirements, and we're going to now implement this. But of course, easier said than done. There's always a little bit more nuance, right? Once we actually get into the nitty gritty of it. So have user input amount. So the first thing we need to do is prompt the user for that. So display message to user requesting an amount, or however you want to word it, right? And then that would end up being a UI feature. So there's a special exception for UI features because they're at the top of the test pyramid. Everything that's at the top of the test pyramid doesn't typically get a unit test, isn't test-driven developed in the sense that we're going to talk about so much. It's user-driven developed, or user test developed, I guess we could say. So anyway, that's noted. So we can go ahead and move down to this next one too. The next requirement for that would be to actually get the user input, right? It's more granular. So we'll get input from user, or get amount. We'll be one more specific. Amount from user. And then that will use the user interface, but there's a caveat because of testing and sanitizing user inputs and whatnot, which we're not going to do today, but I do just want to include that little asterisk there to say, like, noted, you know, any non-trivial program we'd want to do that in, but today we're writing just the MVP, just the trivial thing, just the minimum amount that will work. Display tip amount. So what does that involve? That involves calculating, or I should say calculate tip at 20%. And then we need to actually display it. So that would be display tip amount. And then finally down here, display new amount including tip. So for that we would need to add tip to amount, and then of course display new amount including tip. Display new total, we'll just say. Whatever's enough. These are our sub requirements, right? So we can word them whatever works for us. So that would be UI. This would be UI. And then these other things, the red flag or green flag or whatever color flag we want to call it here would be calculations and conditions. Those especially are the two things that we want to test drive. We don't want to include those inline in any type of user code. We want to pull those out into its own little thing and be able to test that in isolation, because that's where the problems are likely to happen. Okay, so we come over here, we can see we've got total just empty skeleton. I called it tip calc for my, here's the actual main program, so it's class tip calc, and we got the public static main void and all that boilerplate. And the same thing for tests. It's an identical boilerplate with just tests appended. I'm not using a third-party testing framework. This should apply for the most part to third-party testing frameworks like JUnit and whatnot, but this, you know, that hopefully then there won't be any specifics to those frameworks in here. But of course there'll be a couple things I have to do manually that those things may take care of a little bit more automated. For one thing, I won't be using annotations. I'll just be prefixing the tests with test underscore, stuff like that. Whatever, no big deal. You're welcome to do stuff adjust how you want, of course. Okay, so first thing I'm going to do is, there's the files in this directory. I'm just going to compile those two Java files. I'm using Java 8 for the record. Here I'm using this version of Java. It doesn't matter though. This should probably work all the way back through Java 1.5, I believe, with the syntax I'm using. Okay, so, and sorry about like, whoa, I was slurring my words and stuttering. I'm just trying to move fast. So I'm going to do Java C, and I'm going to do tip calc star.java. And then we can see we have our two class files there. We'll go ahead and do a Java and run tip calc. Like that. That's good. We don't want any input. And then we'll of course run the test just to make sure there's no syntax errors or whatever. Okay, let's clear the screen. We got a fresh start now. So now we can step over here to the TDD steps because we have our requirements for the most part. So then we can go to this first step, determine the next desired method interface from the perspective of the application code. So that means we jump all the way back over here to tip calc, not the test, because this is where we want to determine that method. And if we look over here at our requirements, we can see the first thing we need to do is have the user input amount, and the very first sub-step of that is display message to user requesting an amount. So that's where we are at. So let's do that. And we can come over here, and since this is UI, this is one of the few exceptions for when we don't have to do test driven per se, right? So we can just go ahead and do this because this code, it just has to be tested the old-fashioned way, so to speak. And it should be tested the old-fashioned way. And then if we want to automate it, fine. But for now, anyway, here we go. Make sure I'm in just regular old tip calc, not the test, and I'm going to do, and you know, this could be like a swing user interface or web interface or whatever, right? But we're just using the command line for this example, and we want to say enter an amount, and then we're going to use the $sign for now, and that's that. I'm going to save it, and that fulfills that requirement. Let's go ahead and user test it. So we will compile it, and then we will run it like that. And there it is, enter amount, just like we expect. Not fully functional, of course, but there's we get what we're expecting. So that passes that part. Let's go ahead and change these to something more like this. And then I'll just change all these, and then we can mark them as we go here. Okay, so this one's done. And then we need to get amount from user. This will just be UI for now. We're not going to do any sanitization or any real testing or catching exceptions. We'll just let the program crash if they somehow manage to punch in a bad value. But if they punch in something sensible, we'll take it. And this is what we'll get feedback on. So what am I doing? I'm copying the line above. Okay, so we need a string with user input. Quick side note, even if it's graphical user interface or at the command line, I tend to just store everything as a string because that's what it is when it comes in as user input. From my experience, it usually isn't like a number or anything like that, at least from text-based boxes and inputs like that. So I like to just keep it as is, and it's just much more easy than anyway, do it how you want, but that's why I do it like that. Okay, so I'm tempted to call it input, but I want to do one better. I'll call it amount, and that's also consistent with what we've been wording here. And of course, we got to do java.util, and I got to remember that new keyword because it's Java, not Python. Scanner, and we're going to use good old system in. Of course, if you did want to do this as test driven, you could do something besides system in and just get the scanner object and then go run that in isolation and yada yada. But what I'm going to do is I'm just going to do this quick and easy way, and then what I demonstrate with test driven development after the fact, you can go around and point that at this particular line and refactor all that and continue to build a much more mature program. But like I said, we're just doing it like that, so that should allow us to get input unless I have a syntax error. So let's go ahead and run that. Compile it first, of course, run it. Okay, now it's asking for an amount. I'll just put 55. Okay, it seemed to take it without, any big problem or fuss. So far, so good. We'll go back to the requirements. We got that. Save it. Now we're on to step 2, display tip amount. So the first thing we need to do here is calculate tip at 20%. So once again, we're still here at the next desired method because we really haven't done any methods, right? We've just done some inline user-facing code, and that's it. But now we're doing a calculation or a condition, so we do need to ideally have that in its own method that can be tested in isolation. And that is calculate tip amount. So from the determine the next desired method interface from the perspective of the application code. So we jump over to the application, not the test just yet, and we look at it and we go, what's the next method interface? And hopefully this example is so easy that you're like, hey, it's calculate tip, just make a method called calculate tip. That's the idea, right? Is it should be that simple, hopefully. So I'll go over here now to test because I'm not allowed to implement new calculations or conditions without a test. I'll come down here and do it. And we're going to put that prefix test calculate tip. And this is just a test. It's not going to take any inputs. And what is the simplest possible, this would be the act section if we're looking at the steps here, right? I'm sorry, I should have gone back and reviewed this step before I went there. So write just enough test code once we determine the desired method name. Write just enough test code for the desired interface in act section to observe the test failing against the application's missing interface code. So just enough against that missing interface. So here's where we say that one, tip, calc, and then it's going to be calculate tip or whatever you want to name it, right? And arguably that's enough right there to make it fail, right? Because that's missing, but I want to put my complete desired interface, which I consider to be the complete desired signature. And just for now, I'll label things like that. So that should be taking a string in my case, and that string is going to be called, well, I can demonstrate some refactoring here in a second. So I'm just going to pass it $20 USD is the implication here for now. And that's that. That's the minimum I can do to get this to fail against that, unless I have a syntax error. So let's check it out. Error, this is the error we want. This is the missing interface. So in the test cannot find symbol with it over that dot, just like that. So that's what we need there. Now we can jump back over because the TDD steps, the next step is write just enough application code implementing an empty method returning the correct type to observe the test passing against the application's incorrect return value. So correct type, incorrect value, skeleton, so to speak. Come over here. This will be, it's supposed to static string, and then we want something like this and that, and it's got to return a string, and it's going to take a string called an amount. There we go. That's the minimum, and it's returning the correct type but the incorrect value, right? So save that, come back over here, compile it. Have I even run the test yet? I haven't been able to run them yet. So here's tests, because before we were just getting a compilation error, right? Now we're actually going to get a runtime. No, we're not going to get a runtime error. We're going to make that compilation error against the missing interface. It's now going to pass. When we, oh, well, it just did actually. We just compiled it. Sorry, trying to run through this so fast. So now we need to do EA to enable assertions because I'm using the built-in assert keyword in Java 1.4 and higher. And then we'll do tip calc test, and then those pass. So it passes at runtime as well. All right. So then we move on to this next step, right? Just enough test code, including an error detail message in assert section to observe a runtime assertion failing as expected against the application's incorrect return value. So of course, there's our incorrect return value. Come over to this thing, our test, and do a assert. You don't have to label them, but I definitely recommend it the first time or few through. And then we're going to assert that our result, and that's another thing up here is we can get the arrange section going just as necessary. Arrange, and we're going to have a string result, and it's initially going to be nothing, and then we'll come down here and it will take the value that comes back from that method, and we want to assert, and since it's a string we got to use the dot equals. We want to assert that it equals the hard-coded 20% tip on $20 would be $4 because 20% is 1/5, right? So, and if we were unsure, we could use a calculator. So $4 is what we want to get back. And if we don't get back, we need the error detail message and say should, or however you want to word it, should equal, and then what I could do at first, I could hard code it. I could say should equals $4. Just for a simple example, I'll do that. And then what I'll do is I'll come down here and I'll say instead we got, and then result. And what I want to do here is I want to make sure, whoa, what's going on? I got a menu up there. Okay, so one reason we're doing this is because we want to make, why is my keyboard's getting, I need to slow down. That's weird how it highlighted this and it won't go away. I don't know what I hit there. Oh, it's because it's an unclosed string. Okay, so one of the purposes here, breathe, is to make sure that this string's all formatted like I like it. That's half of the thing. We want to make sure, of course, the assert actually fails so that we know it will fail. And then we also want to see that the message prints as expected when it does. You may notice I'm doing something wrong here. I'm going to go ahead and let it play out to just case in point why we want to write our tests first and watch them fail. So we're compiling. What's it saying? This is a syntax error. This wasn't expected. So I'll just go ahead and fix it, save it, and we'll just start over like that didn't happen right there. And it compiles as expected. And now I'm going to run the tests, and it's going to look like they pass. Because it silently, unless I tell it to print a dot or some sort of signal that the test ran and passed, it looks like it passed otherwise. That's the expected behavior on screen we want from the test. Well, what's going on, of course, is since I'm not using a testing framework or annotations or anything, I need to actually call this method here. So hopefully that demonstrates one of many zillions of reasons why you want to see a test fail, because otherwise if we just get the test to silently pass, quotey fingers, then it might be silently failing effectively. And so we want to see it fail. And the easiest way is to do that up front. It's less steps. So save this. Now recompile it. It should fail for the expected reason, which is that it's going to return a empty string right here, and we come back over here, and we're expecting a string to be $4, 1/5 of that tip. So that assertion should fail. And there it did. And we can see we have nice spacing around our message because I put lots of new lines. You can do it however you want. Should equal $4. We got a blank. We got a blank string back. So I feel like that helps. One thing we can do here too is I can get rid of the $4 and say that it should equal expected, something like that. And then up here I can do string expected equals and then also we can do the same thing if we just get all these variables that change out of here and put them up here. String amount, like so. Then we can do expected right here. So we got amount expected. Then none of this changes other than this name right there. Oops, I got to put an amount in there, don't I? Okay, so which I could have found with a syntax error if I wouldn't have caught that myself. And then so most of the stuff that changes is just right here, which is nice, so we can see all the variables up here at the top. And I'm also going to take this moment to rename this to a better name. The format I'm going to use is the given, test method name, given something, return something, right? So with my given, I like to keep that pretty generic and consistent. So given an amount returns, and then here on the so-called rag that writers and publishers call it, because it's that right side of the column that tends to be all jagged. If you picture, if we fold all our tests together and alphabetize them and all that, if we keep it mostly consistent until the end of this return statement, then we'll get all our tests that are the same or similar all together, and then just vary based on what returns. So I want it to return expected $4, so I'll just literally put that. And really it doesn't matter what you say here, just as long as the test name is unique, right? And so what I need to do now is just, and if I would have forgot, we would have realized that this test wasn't failing as expected, right? Okay, so almost forgot what step we're on over here, or I should say I did. So failing against application's incorrect return value, we saw that. So I just refactored this test. I'm going to go ahead and just double check real quick, do a quick compile. When in doubt, just always take the more granular steps. Okay, got the same error. That's what we expected. Now we can go back over here to the steps and go next one, right? Just enough application code to observe the runtime assertion passing by correcting the return value, first iteration being hard-coded. So we're going to go over here and we're going to return, what are we expecting? Expected $4. So that's what we're going to put right here, $4. And then we will compile and run that. Okay, so now we're witnessing it pass with that $4 amount. So let's jump back over to our steps. Now we refactor application code. That's where we just were right here with this little hard-coded value. To improve obvious weaknesses, repeating steps 4 and 5 to suss out and correct issues as necessary, i.e. remove duplicate hard code. So we're looking for obvious weaknesses, I can't say that word, sorry, in our application code and in our test code even, before we walk away, right? We're not just doing arbitrary stuff. And of course we can see our obvious weakness is that we have hard code or duplication there. And so we want to suss that out. So we do that by repeating steps 4 and 5 here, right? Repeating these 2 steps. So go back, write just enough test code to get the assertion failing, and then write just enough application code to correct it. And we just do that ad infinitum until we're ready to start all the way over with a full rinse and repeat. So we come back here and we see that it's $4. So here's the easy button on this. I can just copy this test, paste it, change what I want it to return. So I'm going to change this to 15. You might want to do it, you might want to make it 1506 or something. I don't know, whatever you feel, but we need to at least change it, right? Come at it from one other angle. $3. And because of the way we have it set up in the arrange section here, we don't have to change anything down there. That all stays the same. If we really want to get crazy, we could even refactor that out to its own little method. So if we ever want to adjust it, we could adjust it in one place and it would read simpler there. I'll just leave that at that. Future exercise. Okay, so that, and then I want to adjust this part that it should return $3 here. And that will suss out that hard-coded thing. Save that, compile it, and run it. And it may seem trivial. It may seem like, why would I want to duplicate that test to do that? You don't have to, but you know what? Who's to say somebody's not going to come back and do the effective refactoring of providing that hard-coded value that only satisfies the first test in the future. So by doing this, we have at least 2 angles of attack to suss out that petty problem. So if you do really care about your code, that's what we do as programmers doing unit tests, is we test what we care about. So I feel like this is a happy medium. I don't feel like it's too redundant, but just to explain that redundancy. Okay, so it appears to have passed. One thing with Java is the way that I'm compiling it with that asterisk, it will silently fail sometimes if the tests are bad, which I don't know if that's me, if I need to enable some other flag probably, but to be totally on the safe side, it's probably best to delete all classes and then do it if you are doing it the manual way like I am. And then, yeah, of course, we need to make sure that EA is there as well, or else it will appear to silently pass as well, because it won't run any assertions. And there is a static assert check we can put in there. I might do that if I remember at the end of the video, but for now, that's not the point of this video. Okay, so, okay, what happened there was obviously we were on this step right enough to see the assertion failing, which we didn't see, right? So that means that I forgot to put this up there again, which is pretty common for me. And there it is. So now recompile and rerun it. And now we can see there's that assertion failing. Should equal $3, got 4. Or if you don't like the word got, that's not the best grammar, right? You could make it say something more grammatically friendly. So at least we know what we got back. So then we could, if we really wanted to here, we could say, what if amount dot equals, just to demonstrate that if we're on the fence with whether or not we should stick, because we're supposed to write the minimum amount of code, right? So this would be following that rule. Of course, in the future, we don't necessarily have to do this, and I won't the next iteration. But if amount equals 20, it's just more hard-coded duplication, then we're going to return 4. Otherwise, we're going to return 3. And there is a point to this madness here. Compile it. Run it and see that it's now passing, right? Of course, with those 2 hard-coded things. So the point also to this madness is that these 2 tests, even though the program's not truly doing what we want, I guess you could say at scale, or whatever, so to speak. It just has these two hard-coded values, but it is doing what we want. So we've managed to go through these little simple cycles, these simple steps, to produce these tests that have the inputs and outputs that we expect in the simplest manner possible, quickest manner possible, arguably, all that kind of stuff. So now we can go refactor more freely, right? So there's the stuff we just did, including the hard code. We even did hard code for a second iteration. You can even do it for another iteration if you really wanted to. It's up to you. I believe in writing wet code initially and then drying it. So now we go back to this step again. Refactor application code to improve obvious weaknesses, repeating steps 4 and 5 to suss out and correct issues. Well, we already sussed out and corrected any initial issues we had there. Or I shouldn't say that. I mean, we sussed out the issue of 4 being hard-coded, but we haven't corrected all of them, right? But we know we don't need to suss out any more issues at this point. It would just be pretty redundant because we have hard-coded code, we have duplicated code. We're checking a lot of boxes there for what we care about so far. So we can optionally remove that duplicate hard code, and I consider that is an obvious weakness in my opinion, so I'm going to go ahead and do that. And since my main point that I was getting at originally when I started this next step here was that since we have these two tests, they're upholding that behavior, right? I mean, it seems obvious, and if it does, good. That's the way I want things to be. All right, so we're going to do big decimal because we don't want to use floating points in Java or any language really. We don't want to use IEEE 754 for money. So in this case, one of the easy built-ins is to use big decimal, and big decimal can take a string and it's going to take our amount and it's going to dot multiply that by 0.20 for 20%, and then we want to we've got to do a scale on that. This actually returns a new value because big decimal is immutable, but it has the word set. So we want to set scale 2 decimal positions, and we want to use the constant for round half up. So that will round 0.5 and higher up. You can adjust that however you want, of course. That's just what I prefer. And then we want to return that everything. For now, yeah, it's arguably suboptimal, but of course the saying is do the simplest thing that could possibly work and get it working first, and then go back and measure, tune as necessary, all that kind of thing. So for now, this is the easiest way to stay consistent. And that looks good. Maybe I have a syntax error, maybe I screwed up the calculation, but our 2 tests, I can save it, jump over here, and they'll let us know. I don't even have to do any critical thinking about it. Okay, we've got a compilation error. Big decimal, I forgot new. Nobody's surprised. Or not new there. We need new multiply by new big decimal. Like that. Alright. Again, let's see if I did it. If not, it will tell me, and I can just one step at a time. Okay, I'm going to clear the screen, make it easier to see what's going on here. Let's see what this problem was, starting at the top. We've got on number 11, cannot find symbol big decimal. Makes sense, I'm not using a big fancy IDE, so I've got to do this stuff manually. Big decimal. Alright. And there it looks like it compiled. Then I can go find my command line to run the test with the EA, and they seem to pass. So it's, you know, all I did was I didn't mess with the test. So I shouldn't have forgot to add anything up here, or I shouldn't have screwed anything up in the tests otherwise. So it looks like they're passing. So they've upheld that behavior, that those hard codes upheld what I was expecting. So then I got to go in and do this fancy thing, and I didn't have to worry so much about it, if that makes sense. it's just a lot simpler. It's very clean to go in and suss out a few tests real quick, and then to be able to come in and just work at this and do like more of a test commit revert style thing on it to be able to get that to work. So now that we've done that, let's jump back over to the steps. So that's the last step there. So before we walk away, we're looking for obvious weaknesses. Is there any obvious weakness here in the application code? I'm not seeing it. I mean, I'm sure there is, but it's not obvious, whatever it is to me. And then with my tests as well, nothing too obvious. Yeah, I could see a couple ways I could refactor, like I said, to maybe remove this assert duplication and turn that into a method or whatever. But anyway, the actual goods of the test look pretty good. We've got the act, we've got the assert, we have everything arranged at top. No obvious weaknesses. So that means we can finally go back over to our requirements, check off that one, move down. Yay, take a breath. We're back to UI, so we don't have to test drive it into existence. We just get to go over here. I didn't even look at what it was. Display tip amount. So we come over here, go up to the top, go to the next one here, and just say print line tip. I'll put a $sign in there, and then plus amount. And as we can see here, there's no conditional, there's no calculation going on. This is literally just appending to that string. If you were super worried about it, you could make this a method call that appends it to the string and make sure it does it how you want. That's fine, right? That's up to you. But for me, and for this simple example, this is good enough. Save it, jump over here, compile it, and I'll go ahead and run the test again just to be thorough. But what we're really going for, of course, is to run tip calc like that. And let's enter an amount. What's an easy amount? $12. How about that? There we go. Tip amount $12. What's interesting is there's not the 0.00 on there. So here's an instance where the user test found something for me. If I really cared, I could go write a unit test to uphold this. But for me right now, what I'm going to do is just go in here and correct it my good old way. And the cool thing is that those unit tests, again, will continue to uphold that core behavior that I want, so that I know I can do this and not worry about screwing up. I'm just adjusting the looks and not the lower level behavior. So we'll compile it. And definitely now I want to run those unit tests to make sure I upheld that behavior, and then we'll run it, and I'll put in 12 with no decimal, and I still got back 12 with no decimal. Multiply, set scale, round half by up, to string, calculate tip. Big decimal, set scale, round up. What am I? Yeah, tip's only $12. Whoa. Or tip's $12. What did I do there? Expected 3. Why is all this passing now? It's probably totally obvious. I'm going to delete all the classes. del star.class. I know it's probably obvious. Sorry, I'm an idiot. Okay, then I'm going to do java c tip calc star.java. See if all that compiles without issue. That compiles without issue. Okay, so it must be when I added those parentheses that screwed everything up. Big decimal amount dot multiply by the hard-coded tip. That is so weird. Big decimal amount. What the heck is going on here? All right. I don't get why my tests aren't failing against that. Expected $4 for 20. Okay, is 12 just the amount that's not working? So if I do 20, I get 20 back. Why is this not working? Why is that not catching things? I require $4, return 3, return 4. If I double click that, that's up there. If I double click that, that's up there. It's running this calculate tip amount. We come over here, calculate tip amount. What is it up here? Am I doing something wrong right here? Amount. I'm saying plus amount. Okay. Spot where a user level test can obviously go wrong. That's totally my bad. Calculate tip. I'm going to leave it in there for now. This is an ephemeral video. It's going in the trash bin, but I'm going to leave that in just to whatever. Sorry, it's an extra couple minutes on the thing or whatever, but I like to leave some mistakes like that in. That one's a little bit more goofy of a mistake than I prefer to make in person, but whatever. Okay, now it's mad because can't find symbol calculate. Tip is spelled wrong. Calculate. Okay, there we go. And I can double. There we go. Okay, breathe. Then we're going to run the test. And then we'll run this. Now, 12. There we go. 240 back. Okay. So that was, of course, always working right, and our tests were proving that. That should have told me right away. I should have just known that to go look at the last line I just pitted. I'm sure everybody else watching knew that and has now turned off the video thinking, what an idiot. Rightfully so, thinking, what an idiot, but hopefully going forward, you're still here. Okay, so now that we have that, I just got to figure out what step of what part. So display tip amount in UI, we did that, so we can check that off. Oops. And of course, that's another reason to user test every step along the way, which I'm sure everybody already knows. So we're now at number 3, display new amount including tip. The first of that is add tip to amount. So back over here, the steps, back to the top, determine next desired method. Let's say add tip to amount, why not? So back to the steps, write just enough test code to see the test failing against the missing thing in act. So let's go over here and say add tip to amount. And then we want to say given tip and amount returns. What are we going to give it? We're going to give it $20. So $4 plus 20 would be $24. So return $20. And if we needed to go and implement part of it before we went up and finished the test name, that's fine too. And so we're going to have at least the act section at first, right? What I can do really is just copy this stuff right here if I'm careful. And so we're going to give it $20. We're going to expect 24. We're also going to give it a tip. String tip equals 4.00. We'll line these up nice and pretty. And then we just, of course, want to change this to match this one. Oops. Like that. It's going to take that and a tip, comma, amount. And one thing this demonstrates, that it's just a personal little design flavor of mine, is I like to avoid redundancy in names if a good name for the variables, because I tend to try and name variables well, local variables well and stuff in these types of situations. So right here I have add tip to amount, tip amount, right? So if I feel confident that I'll use those kind of names, I can just go ahead and get rid of that redundancy there and just do it like that and just call this an add method here. But again, personal design decision. So I'm just going to double check this since I copied and pasted. I have amount, $20 tip, that result tip, calling the right thing with the right parameters. all these are passed in I usually use result and expected for the names of those so that they're much more universal. And okay, I'm going to save it. And jumping back over here to the steps, we need to observe the test failing against the application's missing interface. Compile it. We got a syntax error on line 40. Line 40, forgot that. Try and compile it again. We got another syntax error, reached end of file. I forgot to close off the method. Of course, your fancy bloated IDE probably told you. I prefer to just do that instead of have my thing burning diesel fuel in my face because it's running so hot. Okay, what do you got here? Can't find symbol, that's what we're looking for. Add tip to amount. And so we can now, following the steps, move up one. Write just enough application code implementing empty method returning correct type to observe the test passing against the application's incorrect return value. So we'll jump over here to the application code. Tip is going to be a string, and amount is also going to be a string. And then we could just return an empty string. Strings are easy in that sense. We've got to think a little bit more for returning a number. Like sometimes if a positive number, we have to basically return like an out of band or type of sentinel value, right? We don't want to return a proper expected value. Okay, so there's all that. I'll save it, jump over here. That should get the compilation interface test to be quiet, but not me. Okay, so there's that. And then if we even run those tests, they still seem to pass. So, of course, we need to deal with that. We need to come back over here and go to this next step, right? Just enough test code, including an error detail message and a search section to observe a runtime assertion failing as expected against the application's incorrect return code. So, let's do it. Come over here. What do we have? We already have the assertion, right? Which that was a little bit premature. I should have commented it out, but anyway. Why is that not failing? Ooh. So what we did was we knocked out 2 steps at once. So it was because I forgot to call this. But what I'm going to do now is I am going to comment that out, save it. I don't know, it's kind of pointless. I mean, I've already demonstrated it, but just to follow the proper procedure, it's going to have the same effect. It's going to just do the same thing, right? And then if we were to come over here following the proper steps, we re-enable it and rerun it, we would again see that it didn't fail against the thing. So that tells us to come up here, paste that in to actually call it, which I love it when I accidentally mess up like that, because then that just reminds me the value of testing first. Alright, and there we go. We should equal 24. Got that. Alright, so then we just jump back over, do the same old thing. Oh, you want 24? Which I'll show in this step. We'll move this one, right? Just enough application code to observe the assertion passing by correcting the return value, first iteration being hard-coded. I know it's super redundant, but that's what hopefully it's so super redundant you feel like you already know these steps, even if you didn't know these exact steps, even if you had slightly different ones yourself. That's the type of easiness my goal is. Okay, there, everything's quietly passing, it seems to be. So just follow the same exact thing. We need to suss that out right here, right? Next step, refactor obvious weaknesses is the hard code. Let's get it out of there. How do we do it? Let's duplicate this bad boy and come up here. We're going to just make some alterations. We'll just keep it boring for now and just change this to 15 with 3, and we expect an 18, and we're going to change this to we expect 18, and looks good. Just skimming down, still got the right method. We copied the right test, and we're not calling it, so we need to call that. No harm in actually remembering to call it. We don't have to forget that step. Of course, you know, if you have a test framework with annotations and whatnot, it probably takes care of that for you. All right, and then we'll run those tests. And we've got should equal 18, getting back that hard-coded 24. So we'll jump over here. And now, you know, it's up to us if we feel like if we're on the fence, duplicate it, you know, do another hard-code iteration. If not, hey, we've got one test upholding that expected value, and now we're coming at it with a second test. We can just go ahead and knock it out here if we want, if we're comfortable like we are in this situation. So I'll just go ahead and say, okay, add the tip to the amount. What's that going to look like? I'm guessing it's going to look something like this, big decimal. We're going to take the tip, and then we're going to add that to a new big decimal, and that's going to take the amount. I don't know what syntax I'm probably screwing up. And then we want to scale that, scale to a 2, and round half up. And then I gotta prefix that so it gets the right namespace, and then to string. Alright, so let's see if I have any syntax errors. And if I don't have any syntax errors, looks like I do. Expected a closer right here. Alright, let's see if I have any runtime errors. Nope. Tests are passing. We already saw those tests fail, so we know they will. We know it's not something goofy. So that says that implementation we knocked out right there seems to be right. Okay, so let's go back over to our requirements. Add tip to amount. Yep, that's what we supposedly did. So we can check that one off the box. Display new total is our last thing, and it is good old UI, so we don't have to go through those. We only have to user test it. So we can come down here and go system.out.print line, and we're going to say new total or whatever you want to call it, and that's going to be plus add, and then tip to amount, and that's that. And we have an amount value, but we don't have a tip one. So what we can do here, again, this is just a refactor, and our tests are upholding this refactor, and anything that those unit tests aren't, our user test will. So we can go in here and just do this little minor refactoring of a string tip equals like so. And so we will now, just to be thorough, we'll delete star.class, and we'll run that, compile both the Java files, and we'll run the tests, make sure everything's upheld. Where's the, I mean, I could leave EA for even the main one. Okay, so let's put in amount, 12. There we go, 12, 240, $24. If we're not sure about that, let's do 22. Hey, 440, one more, let's do 15. There it is, $3, $18, all looking good. All right, so that was 100% test driven, except for this tiny little top of the pyramid right here. And yeah, that checks that box. So basically, we're done. Everybody could go home or write whatever love or hate you want in comments, if there are any available below this video. And yeah, I guess what I'll cover real quick for anybody that just, I don't know, I like to look at things from a sort of a middle ground perspective, where some people are leaning expert and some people are leaning beginner with stuff. So the leaning beginner people would want to know that over here in tests, what we need to do to make sure that our assertions are actually run, I haven't even done one of these in a minute, so I might goof up the syntax on it, but we need to run a static block. And inside this static block, what we're going to do is we're going to create a Boolean. I honestly can't. Okay, good. I couldn't remember if it was bool or Boolean in Java. I switch back and forth between a few different languages all the time and get the syntax all screwed up. So Boolean, we're going to call it is assert. You can name it whatever you want. Is assert enabled. And we're going to set it to equals false. Is that not the keyword false? I think that's the keyword false. And Java's lowercase. Oh well, we'll find out in a minute. And then what we do is we run, since an assert statement won't be evaluated unless asserts are on, then we say is assert enabled, and then we set it true here, and so it won't get set true if otherwise. And then if what is it? If not is assert enabled, we could let's throw new, I don't even remember the syntax, honestly. Throw new assert, throw new error, throw new assert error. I'm going to do a super quick look it up. Well, I could just print a message if I want, but I want to do it right for the sake of the example. So I'll say Java TDD. Dang it, I know I have my GitHub one. Okay, here we go. This will just take a second. A couple seconds, because everything wants to run slower when I'm doing a little video. And then we can come down here to the assert keyword. Where's the assert keyword in Java? Here it is. And then there should be a static assert block in here somewhere. Come on, static assert block. I know you're in here. Don't even mess with me. Assert copy. There, is this it right here? Asserts enabled. If not enabled, throw new runtime exception. That's what I was wondering about. Okay, so if not enabled, we're going to do this. And I'll even do it like this to make it all fit on the screen. Throw new runtime exception with the exclamation points like they have it. Okay, so I'll save that. See how that's in a static block like that? Just stuff it at the very top right above main. And then we go back out here and compile everything. And then when we run these tests, I'm going to cannot find symbol. Is asserts enabled. A little syntax error. Okay, so now I'm going to try and run them, and I'm going to forget to include this flag here, and then we get that exception in main, asserts must be enabled, right? So what I like to do, honestly, is like freaking, I'll just say enable asserts like that, right? And I'll even do, this is why I do that kind of a thing on there to like really make it stand out. And there it is, enable asserts. So then we know if we go back and put that little EA flag, and I'll usually even say enable asserts with EA flag. And there we see the test pass. And of course, we can do that, and it doesn't even matter if asserts are enabled on this one. Let's just do another amount, 55. There you go. Thanks a lot for watching. Please leave me any sort of feedback whatsoever. If you don't like the way I enunciate my words, I say pit instead of put. Drives me nuts when I review my videos. Anything and everything, of course, especially what you think about these steps, any details that you would prefer that I went into. If you want to challenge anything about any particular step, why it isn't necessary, maybe, feel free to do so, but I would just ask that you provide actual substance, actual evidence of why that step wouldn't be necessary, other than like, I don't like it, or that's not the way I do it. But I mean, even if you just want to say that, that's fine. It's always good to know what people, just everything that's going through somebody's head when they watch the video, as somebody, you know, as people, public speakers, so to speak, pun not intended, but it's good to know. It's good to address every concern that somebody has in their head, even if it's not at length, right? I like to address it and say, hey, I know you might be thinking this or whatever. And anyway, thanks again for watching.